presentation has been has been indicated. We're gonna move on to the second group, and these questions are gonna come up again in a slightly different form. I'm gonna hand it over to Sam, Bruno, and Antonio to introduce the second project in our session.
Thank you.
All right, so my name is Bruno Hernandez. My group is Antonio Vargas and Sam Pruitt, and we are Dimorphos. So we began the semester by researching buoyant objects and creatures that could potentially translate into buoyant vessels and later down the line, buoyant architecture. Between the three of us, there were two things we looked into that we found particularly interesting. One was the floating garbage island and its additive ability to collect objects over time, and two, the kelp's pneumatosis, or air sacs that keep them afloat and buoyant in the water.
After visiting the site for our current project and the Buoyant Vessel project, we analyzed firsthand how the site behaves and the forces that we would need to construct a vessel to counteract with them.
Moving into our Buoyant Vessels project, we initiated the conversation by researching aquatic creatures such as the tuna, which guided the design process. A combination of factors such as its form and bone structure guided the discussion in developing the concept. The main topics and key terms being used to drive the project was agility, maneuverability, and flexure, with consideration of the program of the vessel. The vessel's structure is designed in a way to provide support where the passenger sits and flexure where it needs to turn. It is intended for the vessel to adjust upon circumstance through an intricate connection system of thin wooden members and knots that is integrated with an outer layer of flexible, tabbed, and overlapped series of EPDM rubber strips that establish a barrier between the skipper and the displaced water, while also adapting along with the structure. As the middle leg of the regatta, the performance of the vessel was crucial. A taut yet malleable mechanism precedented by its aquatic biological qualities were intended to ensure its functionality while traversing the water.
Here's our vessel albacore and documentation of the construction process, as well as water testing. From our work in maneuverability and single-axis rotation in the Buoyant Vessels project, we started our buoyant architecture project by looking at Jimenez Lai, who has done extensive research into multi-orientational architecture and spaces intended for the body. Coming out of Project 3 and into our current project, we took our idea of flexure and took it into a deeper conceptual understanding of rotation and orientation. This installation, called White Elephant, is one object. This one object has 8 intended orientations for the human eye. And the space station was a key precedent due to its self-sustainability. This, along with the idea of potential addition of newer modules to allow the architecture to literally grow over time, are things that we had thought would excel our project. The concept of an airlock system that allows one transition from one environment to another was another aspect that seemed appropriate to implement in the project.
In an attempt to create a space where a human body could occupy and a place someone would want to visit, we imagined these pods that would change orientation based on the weather conditions. Each of these pods were designed individually to be below the water, at the water, where one could access by boat and have some sort of docking station as well as shelter, and lastly, above the water. This idea of the 3 orientations would continue on into the next project and would be the driving factor for the concept and programmatic functions of spaces.
This diagram explains how the proposal would behave in the water with its system of paths.
So during calm conditions, the main research pod is able to rotate between all intended programmatic orientations. In addition to this, it is able to exist at, above, and below water level as needed. During fluctuating conditions, the research pod sinks slightly below the water so that the wind won't tip it over. The main docking entry becomes inaccessible at this point, but the additional airlock and submarine docking station are available for usage. During stormy weather conditions, the research pod will totally sink to the bottom so that the occupants won't be thrashed around. This scenario only allows researchers to access one orientation that contains all supporting functions. We determined our project's location by looking over data relating to wave height and water depth within Lake Erie. We specifically chose this location because it's the deepest part of the lake that is relatively close to the shore and has the highest waves on average, which we could utilize as a tool to study the Great Lake. For some context, this is the mile-long break wall with some large cranes operating on it. And this is the Buffalo Outer Harbor over here. This rotation diagram illustrates how the station changes orientation from A to B on the right and B to C on the left. As you can see, the third orientation is intended to sink to take shelter from westerly wind generated gravity waves. These waves span across a 300-mile fetch starting on the west of Lake Erie and end on the east side. This is referred to as a siege event. And animation.
So Dimorphos is a marine biology research center / habitation space that takes on the curvilinear form of an asteroid from its exterior, giving it the ability to maneuver and rotate in the water, using its waffle grid structure as a means of creating a powerful and dense system that can take on the forces of an unstable environment such as Lake Erie. The vessel is able to rotate using a system of ballast powered by the tanks and drains that fill and empty with water in order to change the orientation. This rotation allows for multifunctional spaces on the interior and gives researchers the opportunity to collect biological specimens that form under the water on the exterior of the structure. Its relationship to the water is mechanically important because a space such as this can only operate in an environment like this or outside of the Earth's atmosphere.
Occupation of humans and how they impact how the space is formed is reinforced by the project titled Dimorphos, meaning having two forms, and the asteroid satellite Dimorphos, named after it, became the first celestial body in cosmic history whose form was substantially changed as a result of human intervention. The project will initially house a collection of labs and sample storage centers that study the impact humans have on one of the Earth's largest bodies of fresh water.
Over time, additional modules from multiple countries, US and Canada, can be added onto the research center for long-term study, which are capable of self-sustainability, similar to how the International Space Station operates. These research centers can be approached by boat or single occupant submarines through an underwater docking station. The station's orientation is also contingent on the climate.
And this next animation visualizes the rotation that takes place from orientation A to B to C, as well as showing the original albacore come in and the submarines go out.
So just to give a walkthrough of the spaces, here's where the researcher would dock the boat, enter through here, and have access to restrooms, and go up this ramp from orientation A to orientation B. This is a section of orientation A. This ramp right here is where you'd go from A to B, and this wall here is orientation B. And in the back would be a ramp to orientation C. And this upper floor is an office space and sample storage center. This is a plan of that upper floor with the office and the sample storage. This is a plan of orientation B where the laboratory would be located. And this ramp right here is how it changes from orientation A to B in the laboratory right here. This last plan drawing is of orientation C, where the supporting spaces are located. Here you would enter into the kitchen and a resting space right here, or sorry, right here. And here's that ramp. Here's a ramp right here that goes back up to orientation A. In addition to this, there is a sleeping pod that is this long tube here. This can be utilized in all orientations. And down the stairs are a submarine docking station. And here you can see it a little bit better in this section drawing of orientation C with the submarine and Bruno climbing out of the hatch and Tony sitting in the sleeping space here.
The research station has a lengthy number of supporting systems given its functional performances and site-related requirements. The station utilizes the waffle grid in order to remain stable in its harsh environment, cladded with a system of panels made of a concrete fiber reinforced composite envelope. Operational function of the station is guided by an extensive support system that creates a working environment for researchers to continue their day-to-day activities. This diagram you'll see each ballast has a series of propellers inside them so that when the tanks fill with water, they in turn generate small amounts of electricity for the station. In addition to this, the ventilation system carries a long tube that is connected to a floating ventilation box on the surface of the water so that once the station dives down, the system can continue to run.
This illustration visualizes how researchers would approach the station as it exists over a mile off the coast of Buffalo Outer Harbor. And this illustration shows where the researchers would rest and utilize living orientation during stormy conditions.
Here in the physical models, the expression of the waffle grid can be seen, as well as the attachment of a skin panel. In addition to this, here you can see a section model of how people would use each orientation.
And that's it.
Thank you, guys.
Wow. So let me start a bit of a kind of a small comment. So I mentioned the previous project is a very good presentation. So that I'm looking at this presentation, and I also checked the other project in the mirror boards, and in a way that there is a certain kind of a level of production in the studio, and then this is also another fantastic presentation, right? Drawings are amazing, and all the kind of documentation of your projects throughout slide. Every slide are very carefully drawn. It is amazing. So really, I appreciate it. And then I feel like I shouldn't say this anymore, because all 6 projects kind of hitting the certain level of that professional production. So my question is the form and efficiency. So I mean, as you know, in the structure class, some of the topic is that whatever we make, inevitably we kind of inclined to make that form kind of efficient about the structure. So you know, there's a bending moment, then certain area is thicker than the others because of that bending moment diagram. So your thing is going down, become submarine, and also rotate. So up and down and rotate. So what kind of form? And then your final production, how does it explain that kind of a diverse movement? And also on top of that, the skin, just like kind of a Pongpiru Center or some kind of a 90s engineering-oriented architecture project, the structure, mechanical system is exposed outside of the building. So that just like that, you intentionally exposing kind of ornaments and machines and openings and valves, chambers and so on. But you know that you can, if you want to, you can make a skin out of it. So how did you decide and kind of navigate that kind of formal resolution until now?
Well, initially we just kind of designed like all of the supporting systems and the interior spaces and just wrapped it in some sort of spherical form. We figured that would be a more efficient form in order to rotate it. It was more so by coincidence that some of them peaked out, but we just sort of like the aesthetic of it, so we kept it that way.
So I think that's very honest answer, and then I really like it, because you know there is no like ugly submarine, for example, in real world, right? Because if we want to go down in the water, the shape should be kind of helping that kind of mission of going down to the water. It doesn't. So I mean, so that's why your intentional decision to make it ugly, is somehow connected to your further ambition that you want to go down, you want to go rotate, you want to roll it, and then you want to do anything you want. And then the form of that thing can have a freedom to be anything, right? So that you celebrating it, you attaching things, and so that it's kind of a very futuristic thinking. And then I really like that very individual decision, not based on conventional form and efficiency topic. So it's very unique and attractive to me.
Is it ugly, Jin, or are you saying it's ugly or it's pretty?
Ugly in very positive sense.
Like grotesque. It's like grotesque.
Yeah, I mean, grotesque. Ugly fish is beautiful, is amazing.
Can I just add something? That one issue about the shape of it, is that unlike building a space station in a weightless environment, when you're underwater, there are all kinds of pressure on those surfaces, which makes any kind of uneven corners or dips or valleys or whatever create tensions on that skin that you wouldn't have in a sphere, for example. And I don't know if structurally you looked into that, like what actually happens with that pressure. And the deeper you go, of course, Lake Erie is not all that deep, but at 200 feet, there's an enormous amount of pressure. So that's something that might have to be reinforced from the inside if you wanted to maintain those irregular shapes. Mm-hmm. Just a thought.
Well, it's interesting, Jin. Both of those comments, you're thinking of, let's think about a submarine, which sinks and surfaces. So, and the space station also is, well, the space station is different because it's completely additive. It's like an additive kit of parts, isn't it? Mm. Whereas something that's underwater is typically not an additive kit of parts. It's a sleek outer form, but then the inner form is designed for inhabitation. So the performance of the outer form and the inner form or the inner voids are quite different, yeah? In a sense, I would say both your inner and your outer forms have the same rules attached to them at the moment, so that you get this, what's been referred to as, in a good way, this grotesque organic form, whether you read it inside or outside. And so then that brings me to your representation. I agree, it's a great presentation, fantastic drawings. But I'm a little bit surprised that your interiors are drawn very conventionally. So that we see, actually a stove that, you know, could be purchased at Home Depot in this cooking space. Yes. And we see a very conventional table, and we see a very conventional storage rack for samples. And I'm imagining this form rotating from vertical to horizontal and everything flying. So you can say, no, the table's bolted to the floor. But then you say, how do you use these things when it rotates 90 degrees? How is it occupied when it rotates 90 degrees? And I think that that would be a fascinating topic for you, right? How does it make something usable for the human beings, the researchers, functional, whether it's vertical or horizontal, because that seems to be the crux of your project. So at the moment, the way you're drawing the interiors, I can imagine them, I can see that they're workable when it's vertical. I can't quite see what happens when it rotates. Do you have thoughts on that?
Yeah, we did talk about this quite a bit, but we didn't quite get around to designing like every single object. So
no, but what do you think your approach might be, rather than saying, "Oh, you didn't do this," but you've talked about it, you've thought about it. So what do you think? How do you think you might tackle it?
Well, we talked about using gimbals in order to keep things level once the station rotates. Also, like, for example, like the fridge, we talked about and have like specific compartments that would hold everything so it wouldn't fly around, that sort of thing.
Do you think things might be more, if I think about boats, and John can help here because I'm not a boat person, but boats, pretty much everything is built in, yes? You don't have a lot of loose furniture.
Well, you gimbal the stove and the compass and some other things, and then you gimbal yourself by adjusting to the wave action. Yeah.
So I think this discussion, I think it goes back to kind of form and efficiency. So that even though I admire this kind of a individual, very unique decision about the building form, there is still you can pursue certain rational relationship between the form and the program. For example, even though your interior space is a kind of a L shape or some kind of corridor-like space, but for example, living preferred kind of a position, and then you have a stove and bed a little more kind of a custom and convenient for that position, so that everything works in that way, so that users have to rotate it to eat something. So that form is optimized for the eating with that certain position. Sleeping position goes a certain way, and then it is the most stabilized kind of a shape, and which provide a better dynamics for those functions, and so on and so on. So that in a way that even though that form is three-dimensional, you can kind of find the linkage between this form is designed that way because when it goes down, it will be rotated to do the research, so that this form is better. When it goes up, it is more like a boat, and then you can have a cup of coffee with a friend nicely sitting there. So that the interior design belongs to the discussion of how your form responding to those different behaviors you want to provide, right? So this discussion also connect to John's earlier comment that if you think about fluid dynamics, so the fluid dynamics has a very different engineering disciplines. It's about the aerodynamics, about the water, magnetic dynamics, and so on and so on. And then every form, every corner of the building, every turns deeply related to, is there a chamber there? And is there enough amount of kind of a empty dynamic chamber there or not? Depending on the decision, you can allow that, you know, a kind of a movement and rotation and so on. So it is, I feel like as a designer, this is kind of a very good, very strong statement and the start, and then in a way that this is a very interdisciplinary kind of ambition, that how this form can be justified to provide certain things, so that engineers' fluid dynamic point of view should help this, and also, like Annette said, the actual complete reframing the sense of furniture or millwork to provide supplement the human function. So how we actually arrange it. The toilet, what kind of toilet can happen, which can be used in 2 different positions. I mean, in a way that those are very, very kind of a unknown area, unexplored area. So it's a very
Now, for the U.S. military, the DoD has explored this extensively, and Sam, Bruno, and Antonio have been dabbling in kind of looking at a lot of NASA drawings, looking at DoD drawings of some ships that actually investigated this in, and I think they you hit the nail on the head in terms of trying to figure out what are the juxtapositions for how we live inside of a space that rotates and has 2 orientations. And I think that's like the last project. There's probably like a diagram that one would do as a kind of wrap up post review, now that it's been more well, now that we're discussing it again. You know, we've been trying to wrap our heads around this for a while, and it's a difficult challenge. And I think the 3 of you kind of tackled it in a super experimental way, and I think that's.
Can I make one last
Yes.
suggestion or comment? The idea of making this thing move around so that you can explore things different way, the whole orientation of this object. You need stability for the people living in it. How about the idea of having the exterior make all of the motions and have carved out inside something equivalent to the gimbal, where the whole inner section where people live, the chairs, tables, all of that, always keep a vertical orientation. Then you don't have to design every single little bit of everything that they do in order to deal with the rotation of the object. So, I mean, unlike, again, outer space where, you know, it doesn't really, there is no up. When you're in the water, there is an up and a down, and a right and a left and so forth, starboard and port. So keeping that orientation inside of a rotating thing, I think it would reduce the complexity of it enormously. But I've been blown away with the drawings and the ability to deal with all of those complex curves and forms and so forth. That was a real tour de force.
So I really agree with that comment, John, because that's a spatial complexity we can solve, so that makes architect decision more important. So architect decision to do that, separating those a bit of functions, external system attached to moving object, those decisions can drive this project rather than engineer or aerodynamics person, this doesn't work, change this, and then we no project left after that. So in a way that type of thinking adds the spatial complexity, but very smart thing what designer can do. I really agree with that.
Yeah.
We're arguing about, we have disciplinary battles going on now in these conferences, which I love. Thanks to the 3 of you, really, really inspiring work. Really very experimental. I really enjoyed every conversation we had. And that's
I love the science. I love the science of this. That part of the way the whole project is designed to kind of look into these scientific aspects of it and bring all that to bear. I think that's brilliant, and that's a wonderful approach.
Well, we've got one more to look at, so we can talk more about science and gimbals in the next project. So the last project of the session, I think we're still on time here, which is great, is authored by Brianna and Shavin. So if the 2 of you'd like to introduce yourselves and share your screen, we've got one more to see.